Hello and welcome to this second part of this series where I'm going to go over using Visual Studio Code for writing research code. In the first part of this tutorial, I went through the setup in Ubuntu Linux, and then that setup included setting up the Python environment, but also installing and setting up Visual Studio Code and running your first Hello World example with all this setup. In this second part, I will be going into a little bit more details about how you can use VS Code for uh, for starting a project and modifying or running a project, but also we'll look at some of the useful extensions that enable better productivity in writing code and managing your repositories. For the purpose of both these tutorials, we have a guideline which I have written, and it's linked below. So the idea there is that someone who wants to set this up can effectively follow the text guideline and set up and get things working. If they are struggling with something, they can definitely refer to these videos to solve their issues. So let's begin. We've already done the setting up and installing Visual Studio Code, and we also ran a Hello World example. So in this part, we also set up the virtual environment folders and the locations that are required for getting all the interpreters, Python interpreters. In this part, I will be going over some of the extensions that are useful, but also looking at your first project that is related to let's say machine learning in this case, but it can be anything since we are doing Python, so anything in Python. But with VS Code, you can essentially do any language. So if it's any other language, these similar steps can be taken to get those things done. So for this tutorial, I am using this simple deep learning classifier. So this is a base framework for training neural networks for classification. What this does is it gives you bare minimum scripts and code to train and evaluate deep learning models on image classification problems. So we are not going to change any code here, but just going to clone this and run this, and then maybe try to debug. I can show you the functionality of the debugger, and any other things that are relevant for productivity here. So I've already cloned this repository locally, and as we did in the last video, we can open a terminal and type code space dot, which will open Visual Studio Code window. In this window, you will be able to access projects are organized folders which have all the code for a specific. This we are doing image classification. So when you your project, you do all your files on. You can also search. For example, we want to. So we have a train function, and it's located here and is used in the training script. You can also look at GitHub source control, but I will not go into details for this tutorial. And then there are debugging options, some extensions, and then whatever extension you install here. So for example, I have Remote Explorer which comes with the remote development extension. So in the previous tutorial we already set up Python extension, but I have also installed some other interesting extensions here, and you can explore here, like anything you want to do, you can essentially find that here. So let's just run this this code. So you can see we've already selected the Python environment, which in this case is a new environment that I created just for this task. So when you create you first, like Python environment, all the packages. So in this project we have a requirements file which gives us all the dependencies that are here, and what we can do to start is we can open terminal. So you can say new terminal, right? So it will open a new terminal, but you can also use the keyboard shortcut that is shown here, and it will give you a new terminal. Once you open the terminal, if you have already selected a virtual environment for this project, it will be saved as a configuration for this folder. It will automatically enable that virtual environment, so anything you do here will be happening within that virtual environment. And the way to tell what if it's not enabled or not is to see for this virtual environment identifier, which appears once you have activated a given Python virtual environment. So we can begin by installing all the packages. So you can say pip install requirements, which will install all the packages that are mentioned here in the requirements file. These are the dependencies, and you can see I've already run this because this command takes a while on the first virtual environment setup. So once you have that, you have all the packages that are required for this framework, and then you can run your code. So let's just keep the options as default. Don't, like, right now just run this training script, and you can see if I press F5, it will give me, for the first time, it will give me which debugger we want to use. So we want to use Python. By the way, you can also come here and run and debug and click on debug. It appears not debugging. First time you will see it will download some data, but I've already run this once, so it's ready to go. And then you will see that your code is running, so it's training at epoch 0 and the loss is printed here. So now let's just talk about the debugger for a couple of minutes. So the debugger in VSCode for Python is a live debugger. What that means is that you can let's say you start debugging and you forgot to put a breakpoint, so you can put a breakpoint anytime, like anywhere during the execution that is happening in the background, and the script will start at that debugging breakpoint and pause there. So for example, I put a breakpoint here, and now the code is at this point, and I can inspect different things or use the debugger to debug what we are seeing here. So once you do this breakpoint, you will see a debugger that looks very similar to Visual Studio if you have used that. So on the left side you will see your variables, which are the current local variables within that function, and just below that you can watch different variables and see how they change during the execution. And just below that you can see the call stack. So if you're interested in how we got to this point, you can this point in code, you can see like where it started and you know how many calls have been made to get this point. Then the last bit here is that you can disable the breakpoints throughout your code. So for example, I have put a breakpoint in matrix, but it has been disabled. So if I enable it, you will see that it will go after a while to met. So let's just disable this one, and then so it will go like once it runs the training loop, it will go to the evaluation where these metrics are used, or possibly maybe not. Let's see what's okay, so it will not go here because this function has already been called, but you get the point. Like, you can have the debug option and breakpoints and multiple files around throughout your project, and you can access them from here, so you can enable and disable them. So so that's the interface. And then how you interact with the debugger is you have a debug console, and it's just a Python interpreter that has paused in debug mode, which has all these variables in memory, and you can access those and do different things. For example, let's say we want to see the data, so we can say maybe we run this this line and then get the latest data, right? So that now we have data in target, and then what we can do is here is let's say print the shape of the data, so we know what it looks like. So it looks like there's like 64 images here of 28 by 28 size, and we can do for example plot this, or just see how the data looks like. So let's just write some code for that. So we have data, so we want to extract let's say the first image in this batch, right? And maybe get rid of or maybe the first one, and then get rid of the channels, right? So if I say see the shape, it's now an image. Now the next thing is to convert this into NumPy array. So you can do that by CPU NumPy, right? So AB is equals to this, and if we print now AB is going to be float 32, but it's a NumPy array. Oh, maybe not. Maybe this is yeah. So it's a NumPy ND array, and let's just plot this. So PLT and show AB, and maybe we can, since we are in debugger mode, we cannot we can visualize this. So let's see. No, I think in debugger yes, I think that's some limitation there, so it will be using a different backend, which is not using the GUI. So you can then alternatively, what you can do is you can save it to a temporary location. So let's just call it like a figure, right? And yeah, so once you do that, you will see the file appear. And good thing about VS Code is that you can visualize images as well. So or any other files that you have here, like a JSON file, or for example this one, right? And then figures, you can visualize those, and yeah, you can you can see and then keep this window. So I'm not sure if I talked about this in the first tutorial, but you can explore different files within VS Code by going around, and it will not keep all the files here, just going to keep a temporary viewer and switch between the files. But if you do want to keep this static, you can double click here, and then it will open a new one and then keep that figure there. The other thing you can do is you can split the window, so you can say, like, I want to see the figure while I am looking at the code. We can do that as well, right? I think I spoke about this in the first tutorial. So that's the debugger, and that's pretty much the interface. You have if you have any problems in your code, they will be shown here. If you have any outputs, they'll be here, but most of the time we are looking at either the debug console to debug and look at the data, or the terminal to look at the output of the printouts from your script. So that's the debugger. And then the other interesting bits with VS Code is that the viewer can also be used to view the like in case of a deep learning model, if it's using PyTorch or TensorFlow, and keeping track of the training curves in TensorBoard, you can open that within VS Code. So wherever you have imported from TensorBoard, it will show you a hint which says launch TensorBoard session. So by the way, if you're not aware about TensorBoard, don't worry about this, but for people who are using deep learning models and want to use TensorBoard, this is quite convenient, especially if you are on a server machine where you can remotely connect and see a window, and then it will be running device, but it will be communicating directly to the server and exposing TensorBoard ports. You won't need to do that. It will automatically do that in the background, like port forwarding. Yeah, that will be done. So you can see the TensorBoard. So we can make this bigger, like we discussed in the last video. So you can see that. You can look at some images from your output, like whatever the output is, you can do that. And again, you can also keep this on the side and still be able to let's say keep it here and still be able to debug or edit your code. So I think that's mostly it from the debugging and development side. The other bit that is relevant here is you can have these default options, so you can specify those when debugging. And the way to do that is you come here in the debug run and debug tab, and you click on create a launch file. So it will create a launch.json file, and since we are running a Python files, we select on Python, and this is default settings for this for any project within this framework. And then what we need to add here for providing input arguments to the file is the args entry, where we can provide, let's say, the model. So I'm not sure what the option was. So yeah, so you can provide the model and you can say model, right? And then you can specify the config, which is again a default config from this project. So remember that we are not looking into changing this project, we are just looking into trying out different things and understand how VS Code works. So if I run this, you will see that it will provide those two options to the Python file, and then it will start the training script again. And you will see just my code tag here, which is very relevant for debugging. In cases, for example, you want to look at only your project, which is within this folder, and you don't want to debug step into previously built libraries like Torch or TensorBoard or whatever, like whichever library you're using, you can select this as true. But let's say you want to see the code, maybe there's a bug in existing library and you want to see the code in let's say Torch, right? So you can then put some breakpoints, and you will have to, so it goes to by default. I'm going to do that and looking at your own library. That's pretty much it from the usage side. Next tutorial I will go the remote development, really where this IDE or editor shines. Like it can be very powerful if you can use this for remote development. Before leaving, I will go over some of the extensions that I have mentioned on the GitHub page. So there are a few recommendations here. Some of them are old, so they may not be there. But for example, bracket pair colorizer, it's deprecated, like this package that is mentioned, but there are similar ones here. So let me just search for this and try to get this. So let's say, like, we find one here, so maybe it's yeah, it's this one, let's say, right? So once you install this, it will be, and enables us to do is it colorizes matching bracket. So by colorizing, what I mean is, let's say you can look at multiple levels of bracket. So let's say this one, another one, then another one, another one. So every pair is colorized differently, and what this enables us to do is helps us in debugging. So for cases where brackets are not closed, we can match the color and then find out the place where a fix is needed. So that's one extension. There are other extensions. For example, there is one called resource monitor. So literally display your stats of your, can be your local machine or your remote machine, and those stats are shown. And again, this is the and then battery percentage, RAM. So you can have that. And then for GPUs, machines with GPUs, NVIDIA GPUs specifically, you can have NVIDIA SMI, and it also enables you to do similar resource management or visualization of the resource on connected with, and gives you a machine. So things like this, this GPU here, you can see something on that GPU. Just and you will see the resources will go up. Yeah, so you can see percent usage, 2% usage. There's higher because and then remain the same. The memory is increased a little bit. So you can see those details at a glance, just below your code. And then there is, for example, a reload extension. So in cases where you install a new extension and you require a reload, you can have a reload button at the bottom. If you click that, it will just restart the reload the window, right? So it's a little bit control as well. So for example, what we can do with this. So a little bit more. Other extensions this it enables you. For example, you want only then add the other is quite standard by that or the essentially based on the text of your project will give you quite helpful suggestions, and in my experience it saves me a lot of time in my day-to-day programming. The only downside for this is that it is a paid service, and you have to pay for this, but for most organizations you can get access to this quite easily and get a free access and free account. So that's one. And then if you don't have this, or you cannot pay, like you don't want to pay, you can use another alternative. So there's one called Codium, but there are many, and free for individual users. GitHub Copilot, but less of solutions. So it's these two are how you enable them in code. Find the extension for it. I don't know which one it is, and it will ask you to. So yeah, we sign in and for your case I only to give details. The we will connect to a server on your machine altogether. Terminal. Things. So yeah, and do write them in the comment next video.